Every single day you turn the key in your Ford 150. A silent war is being waged inside your engine, and the primary saboteur isn't wear and tear, it's the factory programming. Ford engineers built a phenomenally capable truck, but the corporate bean counters and emissions lawyers programmed it to sacrifice its own long-term mechanical survival just to chase fractions of a mile per gallon on a government test cycle. You bought your truck thinking the factory settings were optimized to make that engine last for 200,000 miles. But the reality is those settings are actively accelerating component wear while you cruise down the highway entirely unaware. Today, I am exposing 5 factory settings and features that are causing hidden damage and draining your wallet without you ever seeing a check engine light. Setting number 3 has caused more catastrophic timing chain failures in my shop than every aftermarket modification combined. And setting number 1 is so deceptive that most owners actually think it is beneficial to the truck when it is doing the exact opposite, quietly grinding your engine bearings to dust. Let's get into it. Setting 5. The ultra-low target idle and variable displacement oil pump. Setting number 5 is the hyper-low factory idle target combined with Ford's variable displacement oil pump mapping. When you pull up to a red light after a long highway drive, look at your tachometer. If your engine is fully warmed up, that needle is likely dropping all the way down to 500 or 525 RPM. Ford programmed this ultra-low idle to cut fuel consumption to the absolute bare minimum while the truck is stationary. To the average driver, a quiet low idle feels refined. But inside the engine bay, this setting is starving your valve train for protection. Here is the hidden mechanical reality. The EcoBoost and Coyote engines utilize a variable displacement oil pump that adjusts oil pressure based on engine speed and load, rather than traditional engine RPM alone. At a hot idle of 500 RPM, the oil temperature is frequently hovering around 215 Fahrenheit to 220 Fahrenheit, meaning the oil is at its thinnest viscosity. Because the pump is turning so slowly, oil pressure can drop down to a meager 12 to 15 psi. While 15 psi is technically enough to keep the oil pressure warning light from illuminating on your dashboard, it is a nightmare for the top end of your engine. The cylinder heads on these overhead cam engines are the very last components to receive oil. The variable camshaft timing phasers, the hydraulic lash adjusters, and the camshaft journals depend on robust oil pressure to maintain a hydrodynamic boundary layer of protection. When pressure drops down to 12 psi at a hot idle, that protective film thins out completely. The heavy valve springs push the camshaft journals directly against the aluminum cylinder head castings, causing microabrasions every single second you sit in traffic. I have pulled oil samples from trucks that spend hours idling on job sites, and the high concentrations of aluminum and iron in the reports confirm that the metal is physically wearing away. Over time, this lack of pressure causes the VCT phasers to develop internal play, leading to that dreaded cold start rattle that costs upwards of $3,500 to repair. The solution doesn't require buying expensive aftermarket parts or tearing into your front engine cover. You need to raise the factory target idle speed. Using an aftermarket tuning device or a laptop equipped with ForScan diagnostic software, you can access the powertrain control module parameters and increase the hot idle target from 500 RPM up to 625 or 650 RPM. This minor 125 RPM adjustment increases your hot idle oil pressure by nearly 40%, jumping from 12 psi up to a much safer 18 to 20 psi. That extra pressure ensures a continuous pressurized stream of oil reaches the furthest oil galleys in the cylinder heads, keeping your VCT phasers locked tight and preventing premature wear on your camshaft journals without negatively impacting your drivability or noticeably changing your fuel economy. Setting 4. The Intelligent Oil Life Monitor, IOLM. Setting number 4 is one that Ford markets as a high-tech convenience feature, but under real-world conditions, it is creating the exact environment that destroys your turbocharger bearings and timing assembly. It is the Intelligent Oil Life Monitor. Ford tells you that your truck can calculate exactly when its oil needs to be changed based on driving habits, temperature, and towing loads, often allowing intervals to stretch up to 10,000 miles or 1 full year. But here is what Ford doesn't tell you. The computer algorithm inside the PCM cannot physically measure the chemical state of your oil. It can only guess based on mathematical models. The system completely discounts the extreme realities of direct injection engineering. Because your EcoBoost utilizes direct injection, fuel is sprayed directly into the combustion chamber under immense pressures exceeding 2,000 psi. During cold starts and short trips, a small percentage of that raw gasoline bypasses the piston rings and washes down into the oil pan. This is known as fuel dilution, and it is the single greatest enemy of your engine's lubrication system. By the time your truck reaches 5,000 miles on an oil change, the oil viscosity has often dropped from a 5W30 down to a 5W20 or even lower due to gasoline contamination. When you allow the factory oil life monitor to let you drive all the way to 8,000 or 10,000 miles, you aren't running engine oil anymore. You are running a highly diluted mix of oil and solvent. As a veteran technician, I have personally inspected rod bearings and turbocharger center, housing, rotating assemblies from trucks that followed the factory monitor religiously. The results are always the same: severe scoring on the bearing surfaces. The turbochargers on these trucks spin at speeds up to 200,000 RPM and operate at temperatures that can easily exceed 1,000 Fahrenheit under load. They demand pristine oil to keep the shaft floating smoothly inside the brass journal bearings. When you feed those turbos hot, fuel-diluted oil for 10,000 miles, the oil film shears completely, causing metal-on-metal contact that cooks your engine bearings and destroys the turbo seals, leading to massive oil consumption and eventual smoke pouring out of your tailpipe. The fix for this is incredibly straightforward. Fire your factory oil life monitor and establish a hard mechanical interval. Completely ignore the dashboard percentage indicator until it tells you it's at 50% life, because that is exactly when you should be changing it. For any turbocharged Ford engine, you must drop the oil and filter every 5,000 miles or 6 months, whichever comes first. If you use your truck for heavy towing, frequent short trips, or extended idling in extreme cold or heat, cut that interval down to 4,000 miles. Always use a high-quality, full synthetic oil that meets Ford's WSS M2C 961A1 specification, along with an OEM Motorcraft filter that features a proper silicone anti-drainback valve. This simple change in your maintenance behavior stops fuel dilution from ruining your engine components and ensures your turbos are always swimming in fresh, uncompromised lubricant. We have already looked at how Ford's programming starves the top end of your engine at idle, and how their automated oil monitoring system practically forces you to run diluted oil through your turbochargers. But those two settings pale in comparison to how the factory configuration actively sacrifices your transmission and your cylinder heads. To appease federal regulators, setting 3. The factory 10R80 transmission skip-shift strategy setting number 3 is the factory skip-shift logic programmed into every 10-speed 10R80 automatic transmission Ford puts behind these engines. When you take off from a dead stop under normal, light throttle acceleration, watch the digital gear indicator on your instrument cluster. You will see the transmission pull out in first gear, completely bypass second gear, slam straight into third, skip fourth, and jump directly to fifth. Under light loads, your 10-speed transmission is effectively operating as a 5-speed or 6-speed unit. Ford engineered this skip-shift strategy for one reason only: to get the truck into the highest possible gear as quickly as possible during the EPA laboratory fuel economy testing cycle, reducing engine RPM and trimming emissions by microscopic percentages. But out here in the real world, this constant gear skipping is creating a mechanical nightmare inside your transmission case. The 10R80 transmission relies on a complex network of hydraulic solenoids, multi-plate clutch packs, and a one-way roller clutch to smoothly transition between 10 closely spaced gear ratios. When the computer forces a skip shift, like the massive RPM drop from first gear straight to third, it cannot execute a seamless swap. Instead, the transmission control module has to slip the incoming clutch pack excessively to prevent a violent drivetrain jolt. This deliberate programmed clutch slippage generates immense localized friction and thermal spikes inside the clutch packs. I have pulled apart 10 R80 units with fewer than 60,000 miles on them, and the steel friction plates are completely blued from heat, with the paper-thin friction material burnt down to the bare metal. Furthermore, jumping gears forces the engine to operate at a very low RPM under a heavy load, a condition known as engine lugging. When you lug a turbocharged engine in fifth gear at 35 miles per hour, the torque demand is massive, which puts tremendous physical stress on the transmission's torque converter clutch. This leads to the notorious 10-speed shiver, or harsh clunking shifts, that thousands of owners complain about. The constant hydraulic pressure spikes required to force these awkward gear jumps eventually deform the main valve body casing, causing internal fluid pressure leaks that ultimately destroy the transmission's CDF clutch drum. A failure that results in a total loss of forward gears and a $6,000 replacement bill. To fix this, you have to force the transmission computer to do what it should have been doing from the factory. Use every single gear it was built with. The simplest, zero-cost way to alter this behavior is by changing your driving habits. Every time you get into your truck, hit the drive mode button and cycle it into tow.haul mode or sport mode. Both of these factory-programmed modes completely overwrite the standard skip-shift logic, forcing the transmission control module to execute sequential shifting from first to second to third and so on, all the way up to 10th. If you want a permanent solution so you don't have to press a button every single time you start the truck, you can use an aftermarket transmission calibration tune from a reputable Ford specialist. A proper transmission tune keeps the truck in normal mode, but recalibrates the shift points to follow a strict sequential pattern. By ensuring the transmission utilizes second and fourth gears, you eliminate the excessive clutch slippage, drop internal transmission fluid temperatures by up to 20 Fahrenheit, and completely stop the premature destruction of your valve body and clutch packs. Setting 2. The hyper-aggressive engine auto start-stop calibration setting number 2 is the hyper-aggressive factory calibration of the engine auto start-stop system. Ford introduced this feature across the F-150 lineup to shut the engine down entirely the second your truck comes to a complete halt, restarting it the moment your foot leaves the brake pedal. Ford claims this feature saves you money at the pump by eliminating idle fuel consumption. But when you look at the actual engineering reality, the fractions of a cent you save on gasoline are being traded for thousands of dollars in premature mechanical wear on components that were never designed to take that kind of abuse. Let's look at the mechanical science of what happens every time your engine shuts down at a traffic light. When your engine is running, the crankshaft journals float on a microthin, pressurized film of oil held between the journal and the engine bearings. This is called hydrodynamic lubrication, and as long as the crankshaft is spinning and oil pressure is maintained, there is zero metal-on-metal contact. The bearings never actually touch the spinning crankshaft. However, the exact moment the engine shuts off, oil pressure drops to zero. The heavy crankshaft sinks through that microscopic oil film and rests directly on the metal bearing surfaces when the light turns green and the engine restarts. The crankshaft must rotate several times under the immense weight of the pistons and connecting rods before the oil pump can repressurize the oil galleys and recreate that protective hydrodynamic layer. Those first few rotations occur with direct metal-on-metal friction. A traditional engine without auto start-stop will experience roughly 50,000 crank start cycles over its entire operational lifetime. An F-150 equipped with auto start-stop active will experience over 500,000 start cycles in that same lifespan. Ford tells you they used upgraded, low-friction bearing coatings to handle this, but I have personally inspected rod bearings from EcoBoost engines running this system, and those fancy coatings are completely scraped off by 80,000 miles, exposing the copper backing of the bearing and grinding your engine bearings to dust. The damage doesn't stop at the crankshaft bearings. Every single time the engine kills itself at a red light after you've been driving on the highway, the coolant and oil circulation through your turbochargers comes to a dead stop. The center housings of those turbos are glowing hot from exhaust gas temperatures. Without oil and coolant flowing through them to carry that heat away, The stagnant oil trapped inside the turbo bearing channels literally bakes, turning into hard carbon crust known as oil coking. This crust restricts future oil flow, scoring the turbo shafts and leading to total turbocharger failure. The solution is to permanently disable this mechanical suicide switch. While you can press the dashboard button to deactivate it every single time you turn the key, it is far too easy to forget. To disable it permanently without cutting a single wire, you can use 0x4 scan software and a standard OBD2 adapter laptop cable. By plugging into your truck's diagnostic port, you can navigate to the body control module parameters and disable the auto start-stop feature entirely. Alternatively, you can install a simple digital plug-and-play device known as an auto start-stop eliminator behind your physical dash switch, which mechanically remembers your preference to keep the system turned off. By ensuring your engine stays running from the moment you start your journey to the moment you park, you maintain constant, uninterrupted oil pressure, prevent lethal thermal spikes in your turbochargers, and extend the physical life of your main crankshaft bearings by hundreds of thousands of miles. We have uncovered how factory programming sacrifices your valve train, destroys your transmission clutch packs, and grinds your crankshaft bearings down through endless restart cycles. But none of those settings match the pure engineering deception of the final feature on our list. Setting number 1 is the most harmful, insidious programming choice Ford made, because it actively tricks you into thinking your engine is completely healthy when it is actually starving for protection, right under your nose. Setting 1. The dummy dash gauges and artificial engine oil pressure dampening. Setting number 1 is the factory-programmed dummy oil pressure gauge on your instrument cluster, combined with the electronic dampening of the coolant and cylinder head temperature displays. When you sit in the driver's seat of your F-150 and look at that beautiful needle sitting perfectly in the middle of the normal oil pressure sweep, you naturally assume you are looking at a real-time, live mechanical reading of what is happening in the oil pan. But here is the shocking manufacturer reality. That gauge is an absolute lie. It is nothing more than a glorified light bulb attached to a needle. Ford does not install a true fluid pressure sending unit in the engine block of these trucks from the factory. Instead, they thread a cheap, basic on-off pressure switch into the oil galley. This switch is calibrated to trigger at a shockingly low threshold, typically just 4 to 6 psi. When you start your truck, if the engine generates anything greater than 6 psi of oil pressure, the switch closes. The powertrain control module receives this binary yes or no signal and commands the digital or analog needle on your dashboard to sweep right to the center of the gauge. Whether your engine is producing a healthy 40 psi at highway cruise or a critically dangerously low 7 psi while idling hot in traffic, that needle will not move a single millimeter. It sits perfectly, deceptively still. Ford engineered this artificial gauge damping specifically to stop customers from visiting dealership service bays to complain about normal oil pressure fluctuations that occur as an engine warms up. They prioritized preventing customer service phone calls over providing you with the vital diagnostic information needed to save your engine from destruction. The exact same deceptive programming logic is applied to your engine coolant temperature gauge. The PCM is programmed with a massive dead zone right in the middle of the temp gauge sweep. The needle will climb to the center at roughly 185 Fahrenheit, and it will stay locked perfectly in place all the way up to 230 Fahrenheit. If you are towing a heavy trailer up a mountain grade and your EcoBoost or Coyote engine starts working incredibly hot, you have absolutely no idea that your cooling system is reaching its thermal limits. The cylinder head temperatures can be skyrocketing, thinning your oil out to the consistency of water and causing the aluminum heads to micro-warp. But your dashboard will confidently tell you that everything is perfectly fine. By the time that oil pressure or temperature needle finally drops or sps to warn you, the fluid threshold has been breached for miles. The boundary layer of lubrication is completely gone, and you are already in the middle of a catastrophic mechanical failure. Your engine bearings have already been cooked, and your engine is done. The solution to this corporate deception is to bypass the factory dashboard filters and read the raw, unedited sensor data directly from the engine block yourself. You can achieve this by using an aftermarket digital monitor system, like an Edge Insight CTS3, or by mounting a tablet running the Torque Pro app paired with a Bluetooth OBD2 adapter to your dashboard. These devices plug directly into your truck's diagnostic gateway and extract the true, live parameter identification data before the Ford cluster programming has a chance to hide it. Even better, if your F-150 is equipped with the larger 8-inch or 12-inch digital productivity screen in the instrument cluster, you can use FORScan software to rewrite the cluster module code entirely. By changing just a few lines of factory hexadecimal code, you can unlock the digital numerical readouts feature above the coolant and transmission temperature displays. This forces the truck to show you the exact real-time temperature numbers right on your factory screen. The second you see your actual cylinder head temperatures climbing past 225 Fahrenheit, or your real oil pressure, dropping dangerously low, you have the immediate actionable power to back off the throttle, pull over, change your driving conditions, or diagnose a failing cooling component before the truck ever has a chance to leave you stranded on the side of the highway with a blown motor. Conclusion: when you step back and look at the entire picture, it becomes completely clear that owning a modern Ford F-150 requires you to be an active advocate for your own machine. You cannot blindly trust that the factory settings, the dealership service advisors, or the manuals written by corporate lawyers have your truck's long-term mechanical survival in mind. From the ultra-low idle that starves your valve train to the deceptive dummy gauges that blind you to internal thermal stress, these factory configurations are built to push your vehicle past its initial powertrain warranty expiration date. Not to make it a reliable companion for 15 years, but you are not powerless against this programming. By implementing the hard mechanical fixes and software adjustments we have walked through today, manually raising your hot idle speed, ignoring the automated oil monitor in favor of a strict 5,000-mile interval, using sequential shift modes to preserve your 10R80 transmission, permanently disabling the destructive auto start-stop system, and unlocking real-time data monitoring, you are stripping away the corporate compromises. You are taking complete control back from the bean counters and restoring the robust mechanical reliability that your truck was fundamentally engineered to deliver. Take 20 minutes this weekend to look at your truck's settings, check your real maintenance history, and start turning off these digital silent killers one by one. If you want to keep arming yourself with this kind of raw, unfiltered technical breakdown that uncovers what the manufacturers try to hide, make sure you subscribe to the channel and turn on your notifications. My goal is to keep giving you the hands-on shop reality that